On June 1st, 2025, a daring drone attack struck deep within Russian territory, targeting 5 key air bases. These drones, concealed in wooden containers disguised as mobile cabins, were loaded onto trucks and transported by unwitting Russian drivers to locations near the air bases. 41 aircraft were hit, destroying 34% of Russia's strategic bomber fleet, with damage estimated at $7 billion. For Russia, it was devastating news. But for the world, it raised a critical question. Can drones single-handedly dictate the outcome of future wars? This event leads us to a vital discussion at Infographic Vision. Why are drones the most critical modern military asset that every nation is racing to develop? Perhaps the most dramatic shift drones have introduced is the democratization of warfare. No longer do only the wealthiest militaries dominate the skies. Today, a small force can deploy commercial drones outfitted with improvised explosives and achieve devastating tactical results. In asymmetric warfare, this is a revolution. Low-cost drones can harass armored columns, disrupt supply chains, or assassinate high-value targets, all for the price of a used laptop. It levels the playing field. A $20,000 Iranian Shahed 136 drone can destroy a $7 million tank, while a $100 million F-35 jet is a budget breaker. And for traditional superpowers, that's a terrifying prospect, because the more accessible drone warfare becomes, the harder it is to control, and the more devastating its impact on conventional strategies. In the modern combat landscape, knowledge is more than power. It is survival. That's why intelligence, surveillance, and reconnaissance, or ISR drones, are now the backbone of every significant operation. Equipped with ultra-high-definition optical cameras, infrared sensors, synthetic aperture radar, and advanced AI-based target recognition systems, drones don't just capture images, they interpret them. In hostile territory, when a movement behind a building or a shift in temperature could signal an ambush, these machines provide clarity, often when humans cannot. And no pilot is at risk. No extraction needed. No flag-draped coffin follows. Drones can neutralize targets with pinpoint accuracy. Hellfire missiles, smart bombs, airburst munitions, all deployed from thousands of feet above or hundreds of miles away. But it's not just about the elimination. It's about selectivity. Drones hover for hours. They observe, analyze, and wait. They don't blink. They don't fatigue. That patience leads to fewer civilian casualties, more surgical operations, and less diplomatic fallout. It's not just a tactical shift, it's a political one. Imagine a scenario where human reaction time isn't fast enough, where the battlefield is so fluid, so complex, that by the time a human operator makes a decision, the opportunity is gone. This is where autonomous drones take the reins. Powered by real-time data feeds and adaptive AI, they analyze terrain, predict threats, and coordinate their own tactics. They move not just with speed, but with foresight. A drone might adjust its path mid-flight to avoid radar. It might autonomously lock onto an enemy signal. It might, in the very near future, determine whether or not to engage, all without human instruction. We are entering an era where human oversight is no longer a bottleneck. For decades, drones were remotely operated. A pilot sat in a control room, steering the vehicle with a joystick, monitoring feeds, and giving strike commands. But the human mind, no matter how trained, is bound by limitations. Reaction time, fatigue, emotion. Now, autonomy breaks those chains. With machine learning, drones don't just follow pre-planned routes, they make decisions on the fly. They analyze their environment in real time. They adjust altitude to avoid radar. They reroute to evade jamming. They select the most efficient flight path to conserve power or outmaneuver defenses. In some cases, they even identify and categorize targets faster than trained analysts. What once took minutes in a war room now takes milliseconds in the cloud. The next evolution in military AI is not just about navigation or reconnaissance. It's about lethality. Enter loitering munitions, sometimes called kamikaze drones. These aren't just delivery platforms. They're both the sensor and the shooter. They fly, search, identify, and then destroy. No orders needed. In certain battlefields today, these drones are already making kill decisions autonomously. They detect human activity, compare behavior patterns to threat profiles, and if the logic tree aligns, they strike. This isn't science fiction, it's reality, and it's raising one of the most urgent questions in modern war. Should machines have the power to take human life without human oversight? Militaries argue that AI reacts faster, more precisely, with less emotional error. Critics warn that a bug in the code, or worse, a deliberate hack, could trigger catastrophe. Swarm warfare isn't just an idea, it's happening. The concept is deceptively simple. Rather than relying on a few large, expensive machines, deploy many small, cheap ones. A swarm can confuse radar. It can saturate defenses. It can breach even the most sophisticated missile shields. One drone can be shot down. 10 can be intercepted. While most discussions focus on tactical drones, those used for recon or strikes, there is a growing focus on strategic UAVs. These are high-altitude, long-range, satellite-linked systems that perform missions on a global scale. Tracking naval fleets across oceans, monitoring nuclear activity, identifying troop buildups in near real time, mapping terrain for entire invasion campaigns. Strategic drones are not just soldiers. They're eyes, ears, and brain centers. They shape national security decisions, predict enemy movements, and monitor global flashpoints constantly. They give nations the ability to act preemptively, not reactively. And in geopolitics, that timing advantage can change the course of history. From automated strike systems to global surveillance webs, drones are no longer an accessory to warfare. They are the foundation of a new military operating system, one built on speed, precision, and above all, autonomy. Drones began in the sky, but now they command the seas. Nations are deploying unmanned surface vessels, USVs, and unmanned underwater vehicles, UUVs, in growing numbers. These aren't just camera boats. They're combat platforms, reconnaissance tools, and even mine hunters. USVs can patrol oceans autonomously for weeks. UUVs can map the seabed, infiltrate harbors, or even destroy enemy submarines. Armed variants can launch cruise missiles, torpedoes, or anti-ship payloads. And they cost a fraction of traditional warships. No fuel crews, no risk of casualties, just pure programmable force. In 2024, Ukrainian sea drones proved this in real time, sinking or damaging large Russian vessels with small, fast, autonomous boats packed with explosives. The message was clear. You don't need a navy to control the sea anymore. You need code. Beneath the surface, drones are doing something even more strategic and more invisible. UUVs are increasingly used for deep-sea sabotage and intelligence. They're small enough to avoid sonar, quiet enough to pass for sea life, smart enough to map critical undersea infrastructure. That includes underwater internet cables, power lines, naval sonar arrays, submarine channels. In the wrong hands, these drones can cripple communications, blind navies, or cause massive energy disruptions without a single explosion. They can also lay dormant for months, waiting for a remote trigger. These are the underwater equivalents of landmines, except they move, they track, they think. Now imagine dozens, maybe hundreds of drones working together. Naval swarming tactics are already in motion. Dozens of USVs can coordinate through AI, approaching a target from multiple angles. Some jam radar, others blind sensors. A few strike, others linger to finish the job. This isn't just brute force, it's algorithmic ambush. No single drone matters. It's the collective behavior that overwhelms even the most advanced defenses. And unlike human pilots, drones don't panic. But where there's a threat, there's a shield. As drones evolve, so do counter-drone systems, a rapidly growing field that might decide the future of every battlefield. There are 4 main layers of defense: detection, radar, RF scanning, acoustic sensors, and even AI-based visual tracking. Identification, friend or foe. This is critical in chaotic environments. Neutralization, kinetic, bullets, missiles, or specialized anti-drone turrets. Directed energy, lasers that burn drones mid-flight. Electronic warfare, jamming control links or spoofing GPS signals. Drone versus drone, interceptor drones that hunt and capture rogue UAVs. These systems are already being deployed at military bases, government facilities, airports, and even sports stadiums. In future wars, the first battle will be invisible. A swarm of drones against a swarm of jammers, interceptors, and lasers. And the winner might be determined in microseconds. Here's the truth. Drones are no longer rare. Thanks to globalization, 3D printing, and off-the-shelf technology, drones can be built anywhere, from high-tech factories to underground workshops. The result? Mass proliferation. Insurgent groups, cartels, rogue states, all now have access to powerful, customizable UAVs. What once took years of R&D can now be downloaded, printed, and flown in days. And it's not just small drones. Larger systems are being reverse engineered. Nations copy designs, modify firmware, and deploy at scale. The danger isn't just military, it's strategic uncertainty. When everyone has drones, and no one knows how they'll be used, the battlefield becomes unpredictable, unstable, and constantly surveilled. Perhaps the most chilling question of all, who decides to take a life in war? The soldier or the software? Today, many nations insist on human-in-the-loop controls, but battlefield realities are forcing change. Delays cost lives. Manual oversight may not be fast enough. We're seeing the emergence of fully integrated drone doctrines, where every military branch has its own autonomous division, air forces deploying combat UAV squadrons, navies controlling fleets of unmanned submarines and gunships, armies using ground drones for assault, recon, and logistics, intelligence corps tapping into real-time drone surveillance, even space commands planning orbital drone defense systems. This isn't just evolution. It's a new kind of military structure, where soldiers become operators, generals become data commanders, and war becomes a coordinated algorithmic enterprise. In the wars of the 2030s and beyond, the victor may not be the one with the most tanks, but the one with the best network. Drones don't just change tactics, they change geopolitics. Small nations can now threaten larger ones by leveraging drone swarms instead of conventional forces. Proxy wars are fueled with low-cost drones, deniable, disposable, and effective. Surveillance drones create constant tension at borders, from Taiwan to the South China Sea to Eastern Europe. And perhaps most importantly, deterrence is changing. In a drone-driven world, retaliation may come silently, unexpectedly, with zero footprints. A drone may strike miles away from its controller. Attribution becomes murky. Escalation becomes harder to predict and harder to prevent. Swarm intelligence isn't just about numbers, it's about behavior. Inspired by flocks of birds and schools of fish, drones can now communicate laterally, react without central control, adjust to threats dynamically, share data in milliseconds, replace fallen units instantly. In the past, drones were controlled individually. Now they are coordinated like living systems, adaptive, self-healing, and ruthlessly efficient. Each drone is expendable, but the swarm? It's unstoppable. Swarming drones can overwhelm radar, confuse missile systems, and jam communication towers before a defender even reacts. Looking ahead, drones will only grow in importance. Advances in AI, robotics, and material science will enable drones to perform increasingly complex tasks, from autonomous patrols to coordinated swarms. The U.S. Army's Future Tactical Unmanned Aircraft System, set for deployment in 2025, will feature vertical takeoff and landing, enhancing flexibility. Contracts like the $8 million deal for the Jump 20 drone show the investment in next-generation systems. The proliferation of drone technology means non-state actors will also gain access, potentially destabilizing regions. This underscores the need for robust counter-drone defenses and international regulations. As nations race to develop advanced drones, China with its Wing series, Turkey with the Bayraktar TB2, and the U.S. with the MQ-20 Avenger, the global balance of power will shift toward those who master this technology. Drones are more than just tools. They're a paradigm shift in warfare. Their ability to provide real-time intelligence, strike with precision, and operate at low cost and risk makes them the cornerstone of modern military strategy. From Ukraine's battlefields to counterterrorism missions, drones have proven their worth. Yet, their future depends on addressing ethical and legal challenges while harnessing technological advancements. As we've seen, drones are not just the future, they're already shaping the present. Thank you for joining us on Infographic Vision. Don't forget to like, subscribe, and leave a comment. It will help us a lot. Stay tuned for more insights into the technologies transforming our world.